Live from the central coast of California, this is NASA's launch coverage of Sentinel-6, Michael Freilich.
From space, it's just one planet.
Sea level rise is really interesting because the impacts are local, but it's a global problem.
We really need to understand how it's changing. How is it evolving?
Wherever you live on this globe, the oceans will influence you in some form or the other.
We've been measuring the height of the ocean since the beginning of the 90s.
We really need that long duration observation.
And Sentinel-6 is going to allow us to continue that record.
So we can better predict what is the rate of change, what is it going to look like in a year, 5 years, 10 years from now, and so forth.
It really impacts the daily lives of people and their ability to plan for their future.
And that's why humanity has been monitoring global sea level from space with exquisite accuracy for more than 28 years.
A satellite dedicated to uncovering new knowledge about our rising seas deserves to be named after someone who dedicated his life to understanding our oceans.
Earth system science is bigger than any particular agency. It's bigger than any single nation. It's bigger than any single continent. And I surely hope, because humanity requires it, that we make some significant progress in understanding.
You start to realize the importance of understanding what sea level is doing now, and we can use that understanding to know what sea level might be doing in the future.
Scientists around the world are using this data to help people.
The importance of this project and where it touches is on all walks of life all across the world. Sentinel-6, Michael Freilich, is all about water.
And in just about half an hour, this SpaceX rocket will launch the Sentinel-6 Michael Freilich satellite into space to continue the important work of monitoring changes in our oceans around the world. And so it seems fitting, this satellite will begin its flight over top of the largest ocean in the world, the Pacific. Welcome everyone watching on NASA and SpaceX's platforms. Thank you for joining us here at Vandenberg Air Force Base on the coast of Central California. I'm your host, Daryl Nail, and with me is Marina Jurica with NASA's Jet Propulsion Laboratory. So good to have you here.
Oh, thank you so much, Daryl. I'm so honored and excited to be here. The launch pad right behind us, Sentinel-6 getting ready to launch and giving us another decade of sea level observations. The science return is so critical, and I'm so excited to be here.
Now, you're a meteorologist as well, so you know the value of the data that's going to be coming from this satellite once it gets into space and starts working. But now comes the hard part, which is launching it into space.
I know, and I'm feeling so excited to get this Sea Scout launched and into action. I'm so invested in the incredible data that's going to come from this satellite, the legacy that it follows and continues. And we all live on this Earth here together, so we need to make it a better place for everyone.
Well said. And right now, as far as the rocket's concerned, we are go for launch. We'll get an update from Launch Control in a minute. We'll take a look at the pad, though. The rocket looking beautiful out there on Space Launch Complex 4. Now, coming up in the show, we'll learn more about Michael Freilich and why this satellite was renamed after him before he passed away. We'll also talk live with his son and his daughter after the launch.
The satellite he's named for can do some incredible science. We'll show you how it detects sea level changes down to a single centimeter and how it helps forecasters make better predictions about the strength and the path of life-threatening storms like hurricanes.
And just before launch, we'll talk about the cool secondary mission of the landing of SpaceX's first stage booster right back here on land, just a few hundred feet away from the launch pad.
Then after the launch, join us for a live transatlantic conversation about climate with scientists from NASA and ESA, European Space Agency.
But first, let's introduce you to the team of commentators who will be calling the launch today. NASA's Joshua Santora and launch trajectory analyst Philip Hargrove. Gentlemen.
Daryl, Marina, it's a pleasure to be here. Just really an honor, like Marina said. I am Joshua Santor with NASA Communications, and joining me, Philip Hargrove from NASA's Launch Services Program, or LSP. Philip, it's a pleasure to have you with me.
It's a pleasure to be here. Thank you so much for having me.
Yeah, so we are super excited, feeling the energy even from the East Coast, where we are located currently. The launch team, due to COVID environments, we're split across the country right now, trying to very literally distance ourselves. But part of the Launch Services Programs, their services provided, is to keep everybody around the world that needs to be in the loop on what's going on actively in the loop, and that's true for us here today. We are actively listening in to everything happening behind the scenes in the entire countdown procedures. So, Philip, how are things going in the countdown procedures?
Yeah, things are going really great. It's been a big week of preparation, and we're finally in the final stretch, just about 25 minutes or so until launch. It's been a smooth count so far this morning. The teams got on console about 3.5 hours ago, around 6 a.m. Pacific time. And about 15 minutes ago, the NASA chief engineer, Akash Vengani, polled his team. The NASA engineers, the NASA launch manager, Tim Dunn, polled his team to ensure that NASA is ready for launch. And just a few minutes ago, the SpaceX launch director, Eric Kraskowiak, polled his team to ensure that they were ready for fueling, which just began recently. So the range is good as well, which means that the path to space is safe for the rocket and safe for the public, and the Falcon 9 is also proceeding nominally towards launch.
Yeah, all good things. Obviously, lots of teams there involved, and we'll talk about that in just a minute, but want to preview for you the fact that we have an instantaneous launch window today, meaning that we have a single second to be able to fly. We have a backup opportunity available tomorrow if it's needed, but that launch time today is at 9:17:08 Pacific time. Again, a reminder, we're launching from Vandenberg Air Force Base Space Launch Complex 4 there on the West Coast. So for those of you here on the East Coast, that's 12:17:08 Eastern time. So lots more to come. Daryl, we would typically provide you an update on the weather as well, but since you're there experiencing the weather and alongside a professional meteorologist, we'll let you take that one.
Well, we appreciate that, Joshua. Indeed, we are. You know, she's a certified meteorologist, and the weather today when we got up, I mean, it was picture perfect, you know, from the window of the hotel, clear, beautiful sunshine. You can tell how gorgeous it is. Didn't have the fog, but you know, we do have these winds.
Oh, it's so unusual, Daryl. I've been to a dozen launches here at Vandenberg, and I've only seen one of them because there's always fog along the central coastline. But fog needs really calm conditions. And so in order for calm conditions to happen, you can't have wind. But we've got a lot of wind out there today, and that is why we have no fog. But that wind might create a problem. And so that's why we need to keep a close eye on those upper level winds for this rocket. Now you can see behind me, we have a couple of high level clouds out there. Those are just cirrus clouds. I like to call them horsetails, but they are not going to affect the rocket in any way. It's a beautiful day. It's a clear day, but it is a little breezy. Now 50% of launch scrubs are due to weather, and about 30%, Daryl, are due to upper level wind issues.
Yeah.
And so these winds occur basically between 20 to 40,000 feet, so pretty high up in the air. And the rocket, it's like hitting a brick wall when they hit those upper level winds. And upper level winds also change direction with height. So it is not good for the rocket, but I'm sure meteorologists are on top of it this morning at the weather office, and they're going to make that decision right before launch. But taking a look right now at our radar, we can see that it is crystal clear out there, folks. So we have no precipitation to deal with. Like I said, these clouds are not going to be a big issue in any way, shape, or form, which is good. They're just nice high-level cirrus clouds. And looking at our launch weather forecast for the day today, we are 80% go for probability of launch, and that 20% contingency is just for the potential of those winds. So it's looking beautiful. I'm so excited to be here, and I'm so excited to actually see it. Because like I said, I've been here a dozen times, Daryl, and every time we just see so much fog in the area. So this is pretty incredible.
And we're perfectly situated for it here on just the mouth of the Santa Ynez River, spilling into the Pacific Ocean. It is an incredible view. We are blessed indeed.
It is so beautiful. Now, there are teams on opposite ends of the world working on this mission. The satellite will be controlled from the European Space Agency's Operations Center in Darmstadt, Germany.
Yeah, and here at Vandenberg Air Force Base, SpaceX's launch team is working the countdown from their control room, while NASA's Launch Services Program, that you see right there, is at the Mission Directors Center just a few miles away. Now, shortly after Sentinel-6 Michael Freilich is launched, it will start gathering a lot of data about our oceans around the world.
And that data will be collected by high-tech instruments on board the satellite. NASA's research scientist Ben Hamilton explains how.
From an early age, I saw images of the Earth from above. And you just realize how much is going on in the ocean, the variability that's there, the changes that are occurring. It really became a passion of mine to understand what's happening in the ocean. So sea level rise is really interesting because the impacts are local, but it's a global problem. So I've done a lot of work looking at sea level rise in particular locations, but on much broader scales, and with the satellites, we have this global view. So here we can see the satellites orbiting the Earth and where they are right now. Having overlap between the different missions allows us to make a direct comparison. And it's really the information we gain from all of these satellites that tell us about sea level change and allow us to get an understanding of what's happening on an entire climate system. And that really long record that'll exceed 30 years with the Sentinel-6 satellite allows us to have a better understanding of how the Earth's climate is changing. So this is an animation of the Sentinel-6 spacecraft and how it collects information about the sea surface. You can see the radar pulse that's bounced off the surface of the ocean. It measures the time it takes for that pulse to get back, and from that we can pull out the measurement of sea surface height. It's not just scientific curiosity, it really impacts the daily lives of people and their ability to plan for their future. As I started to live in coastal areas and see flooding that was occurring, I got to see firsthand the effects of sea level rise and climate change. You start to realize the importance of understanding what sea level is doing now. We can use that understanding to know what sea level might be doing in the future.
And coming up after the launch, we'll talk live with scientist Josh Willis, who's actually going to perform a live science demonstration about our rising seas. It's going to be something you want to check out.
And he is so incredible. I'm so glad Josh is with us this morning. You may have noticed this satellite was named after Michael Freilich. He led NASA's Earth Science Division for more than a decade.
And he did an outstanding job. Freilich, though, lost his battle with cancer in August of this year. But as you are about to hear, leaders in the space and science community around the world explain why they all agreed to rename this satellite after Michael Freilich.
I was so excited to receive a letter by the European Space Agency and the European Commission proposing that Sentinel-6A should be Sentinel-6 Mike Freilich.
Having a satellite named after you is pretty remarkable. It's not something we do in Earth science very often.
It's not only ESA, it's Europe who wishes to honor Mike Freilich.
Mike Freilich has been instrumental in making Sentinel-6 a satellite that measures with very high precision sea level rise.
The Sentinel missions are something that Mike was very involved in.
It really epitomizes the role that Mike has played over the years as championing partnerships, championing collaborative investigation of the Earth.
Names are reserved for the greats. You don't name after a satellite after somebody who just does their job.
It's the second mission ever named after a person who's alive. It's a huge honor, and I couldn't be more excited.
Through this, we want to pay tribute to a unique cooperation between the US and Europe, and a unique personality, Mike Freilich.
Dr. Mike Freilich is a world-renowned ocean scientist who, after a successful career in academia, came to NASA and for 12 years led all of Earth science.
And he's really brought NASA back on the international stage.
The partnerships that we forge are beyond a business transaction. They are about friendship, and Mike did just that.
Working with our international partners, working with our interagency partners.
And Mike brought that community together in a way that was really unprecedented.
Mike Freilich's legacy is being able to build the coalitions that are necessary for us to get as much understanding of our planet as possible. There is not another person more deserving of this honor than Mike Freilich.
Michael Freilich touched so many people personally and professionally, and you had a chance to listen to him, Ty.
I did. He spoke at an AMS conference, and he was just so moving. His passion for Earth science missions was just incredible, and it was an honor to be able to hear him speak. Now, the Sentinel-6 Michael Freilich satellite has a long journey ahead to get into space.
But before it starts orbiting the Earth, the satellite already traveled halfway around our planet. just to get to the launch pad behind us. NASA's Blair Allen tracked its journey.
On September 24th, Sentinel-6 completed its flight from the Airbus facility near Munich, Germany, to Vandenberg Air Force Base and was transported by truck to the SpaceX facility at Space Launch Complex 4. Upon arrival, it was unpacked in the safe confines of the clean room. A team of scientists, engineers, and technicians began the critical process of preparing the spacecraft for launch. Over the last few weeks, they have thoroughly tested and checked out all aspects of the spacecraft to ensure its readiness for flight. The next critical step, the integration of the spacecraft with the Falcon 9 launch vehicle. Sentinel-6 was carefully encapsulated inside the rocket. Yesterday, Sentinel-6 and the Falcon 9 rolled out of the SpaceX hangar, covering the last few hundred feet of its journey on Earth to reach the pad at Space Launch Complex 4. Once vertical, the rocket is ready for all final checkouts before launch.
Separately, NASA and the European Space Agency have studied the oceans for decades.
But now the two have joined together for Sentinel-6 Michael Freilich. Joining us now is ESA's Guido Livrini, the Copernicus Space Segment Program Manager. Guido, it's great to have you with us.
Thanks for having me.
Well, we just saw video of the rocket rolling out and going vertical on the pad. You can see it there right behind us. It's ready to go. How are you feeling?
It's a big emotion. This project started in ESA more than 10 years ago, so it's been a very long journey. There are many memories that stand out, but the most vivid one is a lecture by Michael Freilich. He was just a few months after his retirement, so he was no longer the NASA director for science division, but he was normal US citizen, and was invited to make a lecture by our director, Josef Aschbacher, in Milano. It was July 19, and he gave us a lecture on international cooperation. Like a gentle, caring father, he made us realize that we don't do enough cooperative mission in Europe on our side. And coming here, I've been thinking about his words quite a lot. And indeed, he was right. If you think of a mission like Sentinel-6 Michael Freilich, it's a mission about sea level rise, it's a mission about climate, it's a mission about safe navigation. There is no reason why a specific agency or a specific country should take action or should care more than anybody else in the world. Yeah. And so you realize that a mission like that, cooperation is the best way to realize a mission like that. And actually, cooperation is the only appropriate way, the only correct way to realize a mission like that.
You're absolutely right. We're all in it together.
That's so true, Guido. And you're right. Michael was such an inspirational speaker, and this collaboration is so beautiful. Now, we have a question from social media for you. Astro Asal on Instagram asks, what is the purpose of choosing this name for this mission?
First of all, we should all be aware of the fact that naming a mission after a person and a living person at the time is a unique event. We don't have any other example of this kind. It was an honor, but we are honored to work for a mission that carries this name. And the answer to the question is super simple. Without Michael Freilich, this mission would have not existed. We will not be standing here today.
Well
so
said.
True.
That's quite the honor. You're right. They do not just name any old satellite after any person. So it's quite an honor. Guido Livrini, with the program manager for the Copernicus program. Thank you so much for spending your time and sharing your thoughts with us.
Thanks for having me.
Thank you, Guido. Guido Livrini with the Space Agency. Thank you.
We appreciate you being here. We want to take a brief moment now to honor our country with the singing of America the Beautiful.
And we're thrilled to bring you a virtual rendition sung by Musica, a group of youth ensembles and youth orchestras from California, Florida, and the Carolinas.
Oh, beautiful for spacious skies, for amber waves of grain, for purple mountain majesties above the fruited plain. America, America, God shed His grace on thee, and crown thy good with brotherhood from sea to shining sea. Oh, beautiful for patriarchy that sees beyond the years, thine alabaster cities gleam under thy humid tears. America, God shed His grace on thee, and crown thy good with brotherhood from sea to shining sea. And crown thy good with brotherhood from sea to shining
Oh, that was so beautiful.
That
And
was
it's so
nice.
great to see all the kids playing and singing. Oh, that was just lovely.
And there's some applause from
I
our
know,
audience
from
gathered
our
here. And
audience here.
That's tough to get everybody in tune when you're not together.
All in separate locations, but so many orchestras and singers across the country are doing just that to keep the arts going.
It was beautiful.
All right. Well, we are now T-minus 10 minutes until launch, and this mission has a special treat for everyone watching. SpaceX is planning to land their booster just a stone's throw away from the launch pad.
Yeah, SpaceX has landed their first stage 65 times, but this is only the third time landing on land here in California. And joining us live to talk about it is SpaceX lead manufacturing engineer, Jessie Anderson. You might
Good
recognize her
morning.
from such popular NASA SpaceX shows as Crew 1, Demo 2. Thanks for being here. It's great having you.
Thank you for having me. I am so excited. I don't think I can even contain it right now.
There, and you see the rocket there on the pad. Isn't that something?
It is a beautiful view, and I'm so excited to see it here in person.
Have you ever seen a launch and a landing in person?
So, not that I haven't tried. I tried to come last year, and, you know, Vandenberg is known for the impeccable fog. So when I came, all I saw was fog. So I heard it, but didn't actually get to see it with my eyes. So I'm really excited that it's a clear and beautiful day today, and hopefully we'll be able to see both launch and landing clearly.
No doubt. It's looking good so far.
Now, for those of people who are unfamiliar with the process, how exactly does the booster landing work?
Oh yeah, this is really cool. So after stage separation, second stage makes its way on its way to orbit, but first stage actually does a flip maneuver. So it continues to gain altitude and actually does kind of like a backflip. And then we have 3 burns that it does. So when it's doing that backflip, it does the boost back burn, which is 3 of the 9 Merlin 1 engines reigniting. And then following the boost back burn, it will do an entry burn to help slow it down as it enters back into the Earth's atmosphere. And then it comes back down and lands with just one single engine for the final landing burn.
It is the neatest thing to see in person, and it is loud. There's a big sonic
So
boom.
loud. Oh, yeah.
You have to even like warn the local residents that it's happening.
Oh yeah.
We want to actually share a special question with you right now. There is a young man, an 8-year-old named Parv. He contacted NASA and shared this picture with it. We want to put it up on the screen. He made a rangoli. This is a traditional decoration for Diwali made of sand, rice powder, and or flower petals in the shape of a rocket. You see it there? There's
It's
Parth.
so beautiful.
He's got a little
He's so
SpaceX shirt on. You
excited.
see that? So they're here for the launch. They're watching. And his question to you, Jessica, is how do NASA and SpaceX achieve the pinpoint accuracy they need to launch?
Oh man, a lot of hard work to sum it up. But there's a number of things. You know, we have to calculate, you know, the orbital mechanics for how to get the satellite into space. But there's tons of sensors and guidance, navigation, control system on the vehicle. The vehicle is completely autonomous. So, as you know, the vehicle is moving so fast, human reaction is not quick enough to guide it. So we actually have it autonomously programmed to make sure that it does everything that we need it to do.
It's amazing, and you guys have gotten so good at it lately. So we're looking forward to that part of it. Jessica Anderson from SpaceX, thanks you so much. You're going to stick around because for the landing, we're going to have you back out, and we're going to enjoy it together.
Yes, I cannot wait. I'm so excited.
All right, fantastic. Thank you, Jessica.
And now we're about T-minus 7 minutes until liftoff of Sentinel-6 Michael Freilich on a SpaceX Falcon 9 rocket.
That's right. The moment is upon us. We're going to hand it over to Joshua Santora and Philip Hargrove for the countdown to launch. Guys, take it away.
Hey, thanks so much. It's been an active past few minutes, starting to hear calls of closeout and things. But before we go too far, I want to, Philip, ask you to introduce us to the teams that are on console today. So there are teams of teams really working this launch. Who do we have on board today?
You're absolutely right. So we have our international partners from the European Space Agency, or ESA, and the NASA Jet Propulsion Lab, or JPL, who have science instruments on board the spacecraft that was developed by ESA. SpaceX obviously manufactured and produced the Falcon 9 rocket, and the NASA Launch Services Program, or LSP team, has been working closely with them for the past couple of years to prepare for today. And the United States Space Force Range is responsible for public safety today.
Yes, grateful for everybody's participation. Lots of good comments made this week during briefings and reviews about just the incredible partnership and collaboration here. So I want to tell you about what's coming up through the rest of the count as we proceed towards liftoff here in just 5 minutes now. We should hear a call for RP1 full in just a second, and then we'll be looking for the strongback retract to take place in just a few seconds.
Propellant tanks are pressurizing for strongback retract.
Perfect. So what that's going to look like on your screen is up near the top of that rocket where the fairing is, just beneath the bottom edge of that fairing. You can see that on screen there very well. There's a clamp that's wrapped around the second stage of the Falcon. That clamp will expand, and then that tower, the strongback or transporter erector, will tilt back just a couple degrees in preparation for the final minutes of countdown. It will still be connected.
Retract has started.
There's that call. The retract has started. That strongback provides power, fluids, and communication for the rocket up until the time of liftoff, when it will tilt back even further away from the rocket. So keep your eyes on that. But Philip, wanted to have you tell us about the path for today's flight. The folks along the southern coast of California might get a treat if they're outside looking up to the sky.
Right. I'm definitely happy for the people out there in Southern California because, we get a million launches out here, but, if they can finally see some, especially at JPL, because it's, they're invested in this launch. So Vandenberg is really convenient for these high inclination launches. So Sentinel-6 Michael Freilich has a 66-degree inclination, which means that it's perfect for the Falcon 9 to launch south-southeast, and it's really going to kind of ride along the coast of Central and South America on its way up to that 1,300-kilometer altitude.
Yeah, very good. We just heard there Tim Dunn coming on the nets and giving his official go. So NASA is go for flight here. The last few minutes here, we're going to hear a number of calls with closing out liquid oxygen or LOX, and then we'll kind of tick down here to the final minutes where we'll hear we're commanded for final pre-launch. We'll have the automated flight termination system will be configured for launch. We'll get a final go from the launch director at around 45 seconds to go on the way to 0 there, right on time for this instantaneous window at 12:17:08 Eastern Time. That's 9:17:08 there on the ground. So, Philip, really fast here as we're waiting for the liftoff. Tell us about the rocket here. You kind of told us about the flight path, but what is this rocket capable of? There's a lot going on here.
Right, there's a lot going on, and we have some beautiful views of this Falcon 9. So you can see it's a two-stage rocket. The first stage, or the booster, goes about 2/3 of the way up, and that actually provides 1.7 million pounds of thrust, which is going to get the vehicle and the spacecraft off of the pad. The second stage, its engine is housed in that black inner stage region that's just below the 5-meter fairing, and that's what's going to finally bring the spacecraft up into its orbit. And as we've discussed already, that first stage, once it separates from the second stage, is going to head on back to Vandenberg.
Awesome. So much coming up here. Post liftoff is certainly active as well. About a minute into flight, we'll hear calls for flight through max Q, or maximum aerodynamic pressure, and then we'll about 2.5. Strong record track has been completed. There you go. You can see a nice separation there between the rocket and that transporter erector. About 2.5 minutes into flight, we're expecting to see a few things happen very rapidly. We're going to see that booster separate after that first stage engine cutoff happens, and then after that separation takes place, the second stage.
Stage 2 LOX load is complete.
There's that stage 2 liquid oxygen load complete, which is great. You kind of see some of the steam coming off the vehicle. That's dealing with cryogenic fluid that's on the order of negative 330 degrees Fahrenheit. It's densified liquid oxygen mixing with the ambient temperature there, which creates that fog, that steam effect. We'll also see a lot more happening post liftoff, so stay with us. And we even have a lot very, very late into the show today. We're roughly an hour and a half of milestones past liftoff of getting into the correct orbit and confirming that we have a good, healthy spacecraft. So please stay with us. There's a ton going on, but we'll let you listen in these last minute and just enjoy the countdown.
Falcon 9 is in startup.
Launch director is go for launch and landing.
You may notice some water beginning to flood the pad here. That's very intentional. That's actually a sound suppression system that occurs to allow the sound of the vibration of the sound to actually be suppressed, and it also helps with some cooling as well.
Falcon 9 is configured for flight.
T-minus 15. 10.
9. 8. 7. 6. 5. 4. 3, 2, 1, 0. And liftoff of Sentinel 6, Michael Freilich, continuing a legacy of ocean observation and international collaboration to benefit all humanity.
M1D propulsion is nominal. M1D propulsion is nominal.
Power and telemetry nominal. Vehicle is supersonic. Vehicle is experiencing maximum aerodynamic pressure.
So there we heard that call for max Q. We also heard vehicle is supersonic, meaning it's traveling faster than the speed of sound. A beautiful shot there from the first stage looking down towards Earth and seeing the plume there created by those 9 Merlin 1D engines. Beautiful clear skies there from Vandenberg on the ground, able to track with that rocket as you see it on screen now. Just a reminder coming up here very quickly, we're going to hear booster or first stage engine cutoff.
Stage separation confirmed.
Booster separation is there, visible on screen now. Beautiful shot. There's the backflip, as Jesse mentioned, beginning with the Falcon booster.
Stage 1 boost back burn has started.
And that second engine looks like it has lit. You can start to see the engine bell there turning an orange.
Vehicles are following nominal trajectories. Fairing separation confirmed.
And there goes the fairing. That's exposed. That is Sentinel 6 Michael Freilich there on your screen. That is the satellite that has been exposed now because the fairings have been jettisoned and separated, and you just saw it there tumbling away. Some beautiful shots on the way to orbit.
And stage 1, boost back burn shutdown.
So we're getting reverse angle views of that engine on screen. That's what you're seeing. This is switching between opposite sides of that second stage.
Vehicles continue to follow nominal trajectories.
And that term nominal being used, we've heard that a lot during this call out. That's a very good sign. Nominal just means that everything is going according to plan within the expectation of operation for the vehicle. So we are, there, a great shot from the first stage. You can see the hypersonic grid fins there that are expanded, those honeycomb-shaped structures. As the booster begins to enter the atmosphere, those will be able to help guide and stabilize the booster to make sure that we hit that pinpoint landing like we heard that question asked. How do we ensure pinpoint landing? And those grid fins play a huge part in that. That second stage is in the middle of its first burn. This burn will last approximately 6.5 minutes. And then there will be a long coast phase today. And then we will have a very short, a relatively short second stage, second burn to put us in the correct orbit to follow that path of the Jason series, as we heard earlier. So, Philip, from a trajectory perspective, is this just kind of a moment where do the people working this mission, do they kind of just sit and wait as well here? Because obviously we're not controlling this actively. It's just the vehicle, in theory, just doing what it's programmed to do.
Right. I mean, I will say I didn't personally work this mission, so I'm not sure what my coworker who worked it for the past couple of years is thinking, but it's beautiful to watch this trajectory that we've been planning out for years. We know what the math looks like, we know what the numbers are, but actually seeing these views from the second stage is just amazing.
Yeah, very good. And we'll talk more about kind of your role and what you do as a trajectory analyst. You are, by all accounts, a rocket scientist, which is pretty cool. We will come back and chat more in a bit. Again, we'll revisit you once we get towards that second stage, second burn. But for now, I think we're ready to head back out to check in with Daryl and Jesse to hopefully enjoy
nominal trajectories.
What I would expect to be a beautiful, very noisy nominal landing of that booster. Daryl, how was launch? How did it look out there? All right, we're going to hang off. They're not quite ready yet. I'm sure they're just enjoying it. They probably got up to watch that launch, and they're probably getting positioned again. So I don't blame them.
Me neither. Yeah, they should definitely soak it in.
So that second stage Merlin vacuum engine, MVAC as we like to call it, that produces around 210,000 pounds of thrust once it's on orbit in the vacuum of space.
Stage 1 entry burn has started.
All right, so call for the entry burn there. I think Daryl and Marina are ready for us. They should be there with Jesse to talk us through the landing. How was launch?
Oh my goodness!
It was incredible.
It was incredible.
That's why we're late. We're all talking at the same time. It's great. Can you tell that we were excited? We were standing there. We saw it. It was so clear we could see the separation as it was going the entire time. Jesse, I mean, isn't that
awe-inspiring?
Mind is blown.
So it's going to be landing right behind us, and we've got a view now of the actual booster coming back. It's got its grid fins out. And that's helpful. It has to use those things.
Yep, it has to help steer it as it's making its way back to land. So it's the steering mechanism.
It's really interesting that it lands right next to the launch pad. We have a little tent over top of us, so we're not going to see that first boost back burn. But we have a clear shot of it coming down onto the pad. The other thing we're waiting for, and we're making sure that we keep track of, is the engine cutoff of stage 2. And we're going to call that out. Here it comes. There it is!
Wow. Oh my goodness.
Coming in at an angle and just straightening out. What do you think, Jesse? That's amazing.
Oh my goodness, I might cry right now.
This is so incredible. Every time I see this, it's just
slowing down so perfectly.
Perfect.
Just hovering. There's the sonic booms we talked about, and touchdown.
Oh my! We heard that.
Oh, that was
And Falcon 9 has landed at LZ4, landing operator
beautiful.
Into 11.100 on recovery 2.
I'm a little
The
teary-eyed right now.
echo of the power to see it here in person, to feel it.
Oh, and like Jesse said, no matter if you see it or not, you always hear it, right? So that sonic boom is recognizable wherever you are.
Reverberating through the valley here.
I know.
Well, what'd you think, Jesse?
Oh, I have no words. That was incredible. Like, as many launches as I've seen, seeing it in person is a whole different experience.
The crowd that's with us, you can hear them cheering and everything. They're just totally like, in awe. We're so glad that we could do this and have you join us with this. Jesse Anderson from SpaceX, lead manufacturing engineer. Thanks so much for coming out here. What a moment.
So much for having me. This has been amazing. Thank you.
Absolutely. Thank you. All right, well, the coast phase is about 45 minutes away, and so we don't expect any activity to report at this time. But if there is, we will let you know. And in the meantime, we'd like to tell you about the science behind the Sentinel-6 Michael Freilich mission. And we're going to get to that in a moment, but we have a moment here where we're going to sync up and simulcast with our partners from the European Space Agency. And when we do that, that's going to allow both channels, both ESA and NASA, to carry the same broadcast at the same time. I'm going to talk a lot about science, and we're going to get to that in a moment. But first of all, I want to get your reaction to watching both the launch and the landing.
It's spectacular, Daryl. I mean, it's so beautiful when everything comes, and like Jesse was saying, a well-choreographed ballet. It's the best choreographed ballet in the world, and it did everything that it was supposed to. The launch was beautiful. I'm so glad the winds quieted down when they were supposed to so that we could get that rocket launched, because this is incredible science that we're going to get from Sentinel-6, and I just can't wait.
Well said indeed. Okay, now we are going to turn it over to our friends from ESA. Let's join moderator Louise Houghton from the European Space Agency.
Sentinel-6 really would like to thank NASA and our friends in the US, also NOAA, for this contribution they have made. Incredible. They have been an excellent partner. They have been very reliable, and they really have delivered their part on time. And in very significant terms. The launcher we have just seen, but also very important instruments like the microradiometer and several other components. And this is a model cooperation I would really like with Thomas and his team in the US discuss further cooperation opportunities, because this is just so wonderful what we have done with Sentinel-6 Michael Freilich, and there is much more to come. I have quite a few ideas. I don't want to go into depth right here, but I think this is so successful that I would like to expand that.
Well, thank you so much, Josef. I think you're saying there that international partnerships are so important for these space missions moving forward. And we've, of course, been able to monitor the oceans from space for nearly 30 years now. And before we continue this conversation, I want to take a look at a video which will show our achievements to date.
Great.
Sorry, this is a little...
You're coming back to me, or?
Yeah, we are.
What would you like to ask me so I can gather my thoughts?
It's okay.
What difference is Sentinel-6 making to revolutionizing oceanography?
We've got time. We've got plenty of time.
We
We'll be out after the video. You'll have like six minutes.
I don't hear the video. I don't hear the video.
She's missing.
She doesn't have a feed. Give me a cue.
Don't do that.
Altimeter was actually an experiment on board Skylab, which was 50 years ago now. I mean, the way that this technology has transformed over this last half a century is quite fantastic, isn't it, Thomas?
Oh, it's amazing. I mean, for me, when you just think about it, you know, you have this spacecraft up there at, 1,300 kilometers, going at 8 kilometers per second, and you're locating it within a centimeter or so, exactly with all these, with the altimeter, but also the GPS receivers and the supporting instrumentation. For me, it's mind-boggling, and of course, it's so important because it affects our lives in a direct fashion every day, even if we don't notice that.
What challenges do you think that we're going to come across in the future with working with this international partnership?
So look, I believe that for the first couple decades, the question really was, are the ocean levels rising? The question to that is absolutely yes. Now, the question that we're dealing with, and as an international community, is how are we handling these rising oceans, and how do we make sure we don't go to levels that we don't need to? And so for us, kind of the local impacts of those around the world, whether it's in Europe, whether it's in the United States, and everywhere else, are what's going to drive our research, and therefore the high resolution that this spacecraft provides us is absolutely critical. So that's the questions the international community has to come together to deal with these problems, because each one of those assets, serves all of us.
Well, we have been hearing more and more about how oceanography has been revolutionized by satellite observation. So Nadia, maybe you can tell us a little bit more about why Sentinel-6 is making such a difference in that development.
Yes, Sentinel-6 is indeed building on a very rich heritage of JSON-class altimeters, and what we expect to see a new science coming out of Sentinel-6, that it would open up new frequencies and give us a fuller picture of what do we know about the oceans. And ocean altimetry, by now, it's a mainstream tool of modern physical oceanography. So if you are a modern oceanographer, at one point of your life, you clearly looked with this data. Either you're studying tides or sea level, ocean circulation, or winds, or hurricane prediction. You were exposed to this data, and we expect from Sentinel-6 to continue doing this discovery on a higher resolution and longer timescales.
Well, if Craig can hear us over in Europe, maybe I can come to you as well, Craig, and ask you your opinion on how this technology is really changing how we monitor the oceans.
Precision, which is essential because the annual changes are just a few millimeters a year. It's really remarkable. But, it can do a lot more. And recent work shows that the oceans are taking up much more carbon dioxide from the atmosphere through the ocean-atmosphere interface, where waves play an extremely important role. Now, the Sentinel-6 Meteor Michael Freilich radar altimeter provides us with excellent measurements of the significant wave height with a 300-meter footprint size along the satellite track. Really, this will help us to improve our understanding of carbon dioxide transfer into the ocean. But it's even more than that. Wave forecasting is part of the Copernicus Marine Services for serving maritime operations, which are essential for maritime safety. And these are managed through the European Maritime Safety Agency. So we'll have topography measurements and wave measurements to really provide something pretty superb.
Well, thank you, Craig.
If you wish, it is up to you.
And that was Craig Donlan, who's the project scientist from ESA, which is a European Space Agency. So thank you so much to them. And the climate science conversation continues. If you would like to tune in, just use the Sentinel-6 hashtag on the European Space Agency or ESA's social media platforms.
This satellite was renamed after American oceanographer Michael Freilich, who led NASA's Earth Science Division for more than a decade. Freilich passed away in August, but 5 months prior, NASA held a satellite renaming ceremony for him at the agency's headquarters in Washington, D.C. Freilich accepted the honor, but he credited his success to the contributions of thousands of scientists, engineers, managers, and diplomats on both sides of the Atlantic.
It's been a privilege to work with you, to learn from you, and to be able to call you friends. The entire world is expecting great things from Sentinel-6, and I know that you will deliver. Go Sentinel-6.
Certainly, he would have been thrilled to see this launch today. Joining us now is Daniel Freilich and Sarah Freilich, Michael's children, son and daughter. Thank you so much for being here.
Thank you so much for having us.
Very welcome. So, you know, you just saw this launch. Your father's name is on the satellite. What were your thoughts as you were watching that?
It was gorgeous. Like, I haven't seen something that beautiful before.
It's amazing.
It's my first time seeing a launch from out here, and to just see that was incredible. Like, it means so much to see and feel it. You know, like, I'd heard him talk about feeling it, and feeling that as it goes is just incredible.
Amazing.
And we all talk about him in the space community as just being such an inspiration. I had the honor of hearing him speak once as well. And you guys know the man outside of the work. So tell us a little bit about him.
So our dad was passionate, and like whatever he chose to do, he wanted to like be a big part of it, and like was in all of the communities. And I like to tell people I didn't have heartthrobs on my wall. I had ESA and satellite images as the posters. And so that was just who my dad was. He shared it with us, and you know, like he was always there.
And I think another thing is, you know, he cared about things at all levels. So not only did he care about an individual mission, but he cared about how it affected the entire world, and he did that with everyone he worked with. You know, he talked about the people that he worked with. He talked about all of the science that happened. When we were going through his papers, actually, we found that he still had the science papers written about the impact on the world. So he, even as he moved on, like, he just cared about every part of the process, the people, the science, and what it meant for humanity.
You guys were sharing a nice moment with me yesterday when you said that, you know, you have talked to the people who worked with him. They talked about you guys, and then he talked to them about you. And so just sharing, you know, the mutual experiences, and said that he was just the real person, the real deal.
Yeah, he would push everyone to be their best in order to make everything better.
And we don't want to forget about Rosie here. This would be his grandchild, right?
His first grandchild that he got to meet, so that was very special. Yeah.
She's rocking the Sentinel-6 shirt. Look at that.
You know, Sarah, you're a science teacher, right? So what part of this kind of carries through to what you do today?
So I think like we do a big unit on climate changing, because like for me, sea level rise and like what we can do as individuals is so important, and like what my father was saying. And so as much as I teach science, and I hope that each student can find something that excites them, whether or not it's like physics, biology, like rising sea levels. But I want to make sure that there's a space for everyone to find something that interests them.
And Michael Freilich had a red pen. Do you have a red pen?
He has a red pen.
Oh, Rosie does.
Yeah, so Rosie got a red pen.
On the tradition, Rosie. Yeah. Just mark it up.
And it's so important, like you said, for future generations to be inspired and make a difference. Yeah, thank you, guys.
That's what he wanted us to understand, that this was our planet and it needed to be better for everyone. And so he always said to us, It's not that there's climate change, but the climate is changing, to try to build unity around this topic and have everyone understand what impacts they can make and why it's important to all of us.
That's very well said. Daniel Freilich, Sarah Freilich, and Rosie.
Yes.
Rosie, we're so glad that you could be here for this moment.
Thank you
It's
so
just
much.
incredible, and thank you for sharing your father's legacy with us.
Thank you for having us.
Thank you
It's
so
really
much for having us.
Michael Freilich believed strongly in the mission documenting sea level rise. Earth's oceans affect us all, from the air we breathe to how they impact our climate. Let's take a look at how Sentinel-6 Michael Freilich will help us continue to explore oceans from space.
Spend a few minutes on any beach and you'll realize just how much the ocean can transform the shoreline. We're here at NASA's Jet Propulsion Laboratory and we're really excited about this new satellite. It will extend the record of sea level rise another decade past the 30 years we already have and allow us to see how sea level is not only rising, but how it's accelerating. This has huge consequences for the planet because sea level rise is one of the most important consequences of human-caused global warming. Sea levels are rising at a faster and faster rate every decade. We need these measurements to help us predict how quickly flooding will increase across the planet. Sentinel-6 will also bring us higher resolution measurements of sea level, which is incredibly important near the coastline where currents are narrow and changes can be difficult to observe from space.
Currents in the ocean tilt the sea surface, making sea level high on one side and low on the other. Also, warm water stands taller than cold, so sea level measurements tell us about both ocean currents and ocean heat.
Ocean currents affect our daily lives because the ocean has a strong impact on climate. In the west, the Pacific Ocean strongly determines droughts and rainfall, and in the east, hurricane forecasting uses satellite altimetry to help predict how much hurricanes will intensify. Ocean conditions can change quickly, and forecasters need data in near real time to predict how currents and marine weather will change across the globe. We're excited about the technical capabilities of this new satellite and the prospect of another 10 years of sea level measurements.
Give a little intro.
And Josh Willis is here, more affectionately known as Climate Elvis, joined by NASA's Blair Allen for a live demonstration.
That's right, Marina. Josh is here. The king is in the building with some
Thank you.
Deep,
Thank you very much.
deep insight into the science of Sentinel-6. So let's start there. Before we get to the demonstration, tell us a little bit about the science behind this mission.
Well, Blair, first I got to say, that was amazing.
I know, right?
I just saw that the rocket went up and then it came back down.
Yeah.
And so did the boom. It lowered the boom on us.
It did lower the boom, even when you know it's coming.
Yeah.
It's still shocking.
Boom.
Yeah.
Sonic boom. It was cool. But
it dropped the mic on us.
It dropped the mic, as I know you were going to do at the end of this segment.
Okay. Well, let's hear it.
So Sentinel-6 is going to tell us about the sea level. It measures the height of the ocean from about 800 miles up, and it does this with an accuracy of just 1 inch. And yeah. Right?
Yeah.
Pretty cool.
Yeah.
And so it does that everywhere in the world, once every 10 days. And from that, we can figure out global sea level rise, how much the oceans are rising because of human-caused climate change. So it's pretty neat.
Yeah. Now, one of our followers on Twitter, Ave, wants to know if they're twin satellites, why are they being launched 5 years apart?
Yeah, that's a great question. They're twins, but one's the younger twin.
Okay.
Okay.
Significantly
younger twin. So yes, so the idea is that we have to keep measuring sea level rise. Sea level rise is not going to stop anytime soon, and we have to keep our eye in the sky looking down on it. So we just launched the first one today. In 5 or 6 years, it'll start to age, and we'll launch the second one, and it will continue the record another full decade. Awesome. And that's a big deal because sea level rise is actually accelerating. So the rate of rise, in the 90s, it was about 2 millimeters per year. In the noughties, it was about 3 millimeters, the noughties, you know, the decade starting in 2000.
I know, but
right.
let's see the demonstration.
Yeah. Oh,
Go
okay,
ahead.
yeah,
Bring
sure.
us to it. Yeah.
Okay, so, all right. What happens when you hold a flame to a balloon?
I'm going to say it pops.
That's right.
But I'm just a layman.
Well, this layman is right. Let's find out right now.
Yep.
In order to do this, I have to put on my safety gear. So here we go.
There you go.
Now we're gonna do this. All right.
Yeah.
And it's gonna pop. Right. Here we
Okay.
go. All right.
Theoretically.
1, 2.
Wow.
It was terrifying, wasn't it?
Frightening.
Frightening, right? Now, what happens when you do the same thing with a balloon filled with water?
I'm assuming it pops as well, right?
Let's find out. Here we go. Look at that.
Fascinating.
Look at that. It's
It
right there.
does.
It's right there on the balloon.
It holds.
It's not popping.
Why not?
It's not popping because water is so good at absorbing heat that it actually takes the heat away from the balloon before the flame can melt it. And that's just like the oceans. The oceans absorb more than 90% of the heat from climate change. So if we think about global warming, it's really ocean warming, right?
Wow.
That's pretty cool, huh?
That is amazing.
I'm really glad it didn't pop. You know, I was afraid I was going to have to give up all faith in science and join the circus or something.
We don't want you to do that.
No.
Well, thanks so much, Josh.
Yeah, you betcha.
It was... Yes. All right. So, science has also left the building along with Josh.
Okay.
Back to you guys at the gravel pit.
I'm going to go join the circus now. Yeah.
Okay. Well, Blair and Josh, thank you so much. I guess he's a hunk of burning balloon or something. Well, anyway, we want to recap the launch now. Just about a little more than 25 minutes ago. We launched from right here at the Vandenberg Air Force Base, courtesy of the 30th Space Force Wing. There it is, the Falcon 9 rocket and Michael Freilich spacecraft on at around 9:17 this morning, Pacific time. 12:17 Eastern time. There you see liftoff. The Falcon 9 rocket soaring into a beautiful blue sky over the central coast of California. The launch was picture perfect. Look at the shot right down the center of the rocket as it left the coast here. The mission to launch the Sentinel 6 Michael Freilich satellite into space. And as it got up off the ground, the launch, it seemed the rocket was taking its time, nice and slow. It's a nice heavy satellite up there. But once it cleared the tower and got up into the upper parts of the atmosphere, boy, it started to race. Michael Freilich's family were on hand to watch the launch, and it was just an incredible sight to behold. A wonderful a time had by all. We had guests and friends and relatives of Michael Freilich out here to watch it. And then just a few seconds later, about 8.5 minutes to be exact, the booster came back down to a nice soft landing. Just several hundred feet away, there came the booster touching back down on the landing pad. SpaceX now able to reuse that booster. And now the spacecraft is in flight and we are tracking its progress. Joshua Santora and Philip Hargrove are keeping an eye on the progress of the launch.
Oh, that was just...
It was something, wasn't it?
Inspirational.
It's incredible.
So beautiful. All right. Well, there are more than half dozen international partners on the Sentinel 6 mission.
Yeah, the European Commission paid to build the satellite earlier, but we spoke to the Europe's ambassador to the United States, Stavros Lambrinidis, about its importance to Europe. Ambassador Lambrinidis, thank you so much for being with us.
Thank you for having me.
I want to ask you, first of all, how important is the data that comes off this satellite for the continent of Europe?
It's supremely important because as we are coming out of COVID and we're trying to rebuild our economy and the health of our people, we're doing so by protecting the climate and protecting the environment. Climate change is an existential threat for all of us, and we need all hands on deck to address that challenge. And, you know, today what we're seeing, what we saw, is an exemplary story of European and American friends working together for the greater good. For Sentinel 6, we pulled together our best engineers, our best scientists, our best resources. We mobilized the public and private sectors to produce the most advanced ocean monitoring data in history.
With that thought, I want to ask you on a personal level, what is the significance of this launch for you?
Well, I'll tell you, as the EU ambassador, I am proud. I am deeply hopeful for the future of our planet, and I am touched. I am proud because Sentinel-6 is at the center of the European Union's Earth observation program, which is called Copernicus. And I'm especially proud that we are making this decisive scientific move in partnership with our American friends.
Back to the partnership. Sentinel-6, Michael Freilich, is actually NASA's first direct partnership with the European Commission. So take me back to the beginning. How did this all come about?
Well, it all came about from a remarkable success story of European cooperation, first of all. So Copernicus came from a cooperation between EU institutions and intergovernmental agencies such as the European Space Agency, the European Organization for the Exploitation of Meteorological Satellites, down to national space agencies and the industry. So this was first and foremost a European success story.
And now that satellite has been launched into space, and we look forward to getting all of that data for the better of the entire world, really. Ambassador Lambrinidis, thank you so much for joining us today.
Thank you. Thank you very much.
Meteorologists understand the critical importance of advance warnings of severe storms across our nation. One of the instruments aboard Sentinel-6, the Global Navigation Satellite System Radio Occultation, or GNSS-RO, will be the next tool for more accurate forecasting. Let's take a look.
Sentinel-6 Michael Freilich will provide important information in producing our daily weather forecast. So how does this work? The data from the GNSS-RO, that stands for Global Navigation Satellite System and Radio Occultation, a new instrument on board, is ingested into the weather models that can help us with our weather forecasting and our warnings to help protect the public.
This mission will use a special technique called radio occultation, which measures tiny changes in the radio signals broadcast by GPS and other navigation satellites. The GNSS-RO instrument essentially measures the time delay of the radio signals as it goes through different layers of the atmosphere. So this allows us to unravel the temperature and moisture content of the atmosphere layer by layer.
Most of the weather that we experience comes from our west over the ocean that lacks conventional observations like what we have over land. The GNSS-RO will help address these challenges by providing us very important temperature and moisture information over the ocean that will help our forecast here on the West Coast.
Studying the entire atmosphere, from the surface all the way up to the stratosphere, is important for us to improve our understanding of our weather and climate change.
We're very excited with the data that the GNSS-RO will provide for these weather models that will ultimately help improve our forecast and warnings to help protect the public.
Eric Louliette is the NOAA, the National Oceanic Atmospheric Administration's program scientist for Sentinel-6. NOAA is one of the Sentinel-6 partners and will use the data from this satellite on a daily basis. Thank you so much for joining us, Eric.
Thank you. It's a really exciting day to see that beautiful launch.
Oh, it was so spectacular. How will Sentinel-6 help meteorologists at NOAA and across the nation? The GNSS-RO instrument will provide a temperature and humidity profile throughout the atmosphere, which is pretty awesome.
Yeah, indeed. We're very excited at NOAA to be using data from all of the instruments. We'll be using from the radar, measurements of winds and waves that will go right onto forecaster screens. We'll be using the sea levels to improve ocean current forecasting, which will help for navigation. We'll also be using those sea levels to measure heat content, which is really important for sustainable fisheries. But as you also say, we saw from that last video how we'll be using the GNSS-RO instrument to profile the atmosphere, measuring humidity and temperature in the layers. And that'll help us do all sorts of improvements to forecasts, including using the atmospheric measurements to monitor hurricanes from their formation all the way through their whole life and dissipation.
And Eric, we have seen great improvements in forecasting hurricane tracks over the years, especially with the launch of Goes East and West. But how will Sentinel-6 help with forecasting the intensity of these storms?
Yeah, one of the reasons that hurricanes can become intense is because they feed off the energy that's stored in the upper layer of the ocean. As you saw from Josh's demonstration with the balloons, the water in the upper layer can store a lot of heat. So what we can do with Sentinel-6 is by measuring sea level, we can measure how much the sea level has expanded. That's a proxy for how much heat there is stored there. So we can figure out how much heat and where it is and map it and send those maps to forecasters. This year alone, we've seen 10 tropical storms increase in intensity rapidly. So it's more important forever that we have than ever that we have Sentinel-6 there for the next decade to monitor and improve hurricane forecasts.
Yes, ocean heat content so important. I always like to think about it as a car that needs gasoline. A hurricane needs that warm water to fuel that engine, that's for sure. Now, what impacts to society do sea level changes have, and how will Sentinel-6 help us better plan and prepare for the future, Eric?
Sure, you know, for the last 30 years, we've been seeing sea levels rise using the satellites that are the predecessors to Sentinel-6. And one of the things we've learned is that sea level doesn't rise at the same rate everywhere. So it's vital that we use Sentinel-6 to map where the sea levels are rising. We've already started seeing flooding both in clear weather from places all the way from Hawaii, the Florida Keys, to Norfolk, Virginia. So we're going to need Sentinel-6 and working with our NASA partners to help make better models to figure out where we should expect increased flooding and storm surges as sea levels continue to rise.
Thank you so much, Eric, for joining us today.
Thank you.
Another fantastic tool on board is Sentinel-6 is the Advanced Microwave Radiometer for Climate, or the AMRC. And the person who led the testing and integration was JPL's Shannon Statham.
In order to be good custodians of our planet, we really need to understand how it's changing. How is it evolving? And here we are at High Bay 2. This is actually a clean room, and each component gets tested on its own, and then we assemble it together. So my team was responsible for assembling, testing, and delivering AMRC for the Sentinel-6 mission. And this is where we built it. AMRC is the Advanced Microwave Radiometer, one of a suite of instruments that work together on Sentinel-6 and then give us the very high resolution heights of the oceans. So we are in the antenna range at JPL, and this is where we tested AMRC. We need to know that what we send into space is going to survive. I've always had an affinity for arts, singing and dancing, and so one of the things I've been doing more recently is sewing. And my dress, I actually sewed. You cannot do this job without being creative. Every mission